Section 3.2 Interactive Assignment Objective 2. We want to be able to find the population standard deviation for the given data. 5, 6, 12. We're going to round it to 2 decimal places as needed. So let's go ahead and take a look here. Well, first we need to know what is the formula for the population standard deviation. Well, it's very important to understand that the population standard deviation is the following formula. We're taking the sum of the deviation squared. So the numerator is going to be the sum of the deviation squared, dividing it by the population size of capital N, and then we're going to take the square root of that. Okay? Now, the first thing we need to do is we are given these values. So we're going to create a first column, which is our score, which is the data value. And the scores that we have are 5, 12, 26, 31, and then 36. Okay? And so what we want to do is we want to find the mean. So in order to find the population mean, we're going to take the sum of those data values, which is 110, and we're going to divide it by the number of values that we have, which is 5, which gives us a population mean of 22. So what that means is we're going to create a second column that is the population mean. And if you notice, the population mean is 22 for each cell. Okay, now the next thing that we want to do is we want to take the deviation about the mean, which means we need to take the data value, which is x, and then we're going to subtract the population mean. Okay, so the first thing we're going to do is take the value of x, which is 5, and then we're going to subtract the mean of 22 to give us a deviation of negative 17. Next, we're going to take the next x value, which is 12, and then we're going to subtract the population mean of 22 to get a deviation of negative 10. Next, we're going to take the data value of 26, and then we're going to subtract the population mean of 22 to get a deviation of 4. Okay, next we're going to take the data value of 31, and then we're going to subtract the population mean of 22 to get a deviation of 9. And then the last one, we're taking a data value of 36, and then we're going to subtract the population mean of 22 to get 14. Okay, now whenever we add the deviations about the mean, when we add all these numbers up, okay, we should get a value of 0 in that column. Okay, now the last column that we want to work with is to take the deviation and then square it. So what do we found in this third column? We're going to take this negative 17 and then square it. So if we take negative 17 and then square it, then we're going to get positive 289. Next, we're going to take negative 10, which is the deviation, and square it, and we get positive 100. Okay, next we're going to take the deviation of 4 and then square it to get 16. Next, we're going to take the deviation of 9 and square it to get 81. And then last, we're going to take the deviation of 14 and square it to get 196. Okay, so now what we're going to do with this last column is to add up all these square deviations. So the sum of the square deviations is going to equal 289 plus 100 plus 16 plus 81 plus 196, which is going to give us 682. And now we're going to plug this into our formula. Okay, so here is our formula. We know that the sum of the square deviations is 682. So that means in the numerator, underneath the radical, we're going to get 682. Okay, and we also know that the sample, the population size, is 5. So that means n is equal to 5. So when we take 682 and divide it by 5, then we get the following. We're going to get 136.4. When we take the square root of that, we get 11.6790410.6. And we're rounding this to 2 decimal places, which gives us 11.68. Now remember that the population standard deviation has a symbol of sigma. So therefore, sigma is going to equal 11.68. And when we take a look at our answer, the standard deviation is 11.68.